Hello everybody, and welcome to your linear algebra review on the transpose of a matrix. My name is Jason, and I work for the ASU Tutoring Centers. So before we get into this problem, let's first discuss what the transpose is. So say I give you some arbitrary matrix. I'll call it M, and I'll just write like A, B, C, D. Give you some arbitrary matrix. Now, if I want to look at M transpose, that's what that little T is. That's transpose. So if I want to look at M transpose, what I'm doing is I'm taking all of the columns from M and I'm now writing them as rows. So my first column of M becomes my first row of M. And my second column of M becomes my second row. So you're swapping all your rows with all your columns. And keep in mind, we could have done this the other way around, right? We could have said, I'm taking this row, my first row, and making it my first column of the transpose. And same thing down here. Say second row to become second column. So it doesn't matter whether you're taking rows and making them columns or columns making them rows, it's the same thing. So all you're doing is swapping rows and columns. And something else, what if we were to do this a second time? What if we were to go ahead and take the transpose of the transpose? So I already took the transpose and now I'm transposing that. So I'm finding the transpose of this matrix. So what do? I take my first column and I write that as my first row. And I take my second column and I write that as my second row. But what is this? A, B, C, D? Well, that's just my original matrix. And hopefully that makes sense, right? Because what we do with transpose, we swap the rows and columns. So if we transpose again, we're basically swapping them back. So we get our original matrix. Okay, so that's what a transpose is. Now, let's discuss some properties of the transposition, okay? First property is, say you have some arbitrary matrix, I'll call it, I don't know, M, and you have another arbitrary matrix, N. If you want to look at M plus N transpose, that's the same thing as M transpose plus N transpose. So you can essentially think about like distributing the transpose in. You can do that through addition and also through subtraction. Okay. Second property, if you are multiplying by a scalar, so say you have some scalar alpha times some matrix M, and you're looking at that transpose, well, you can actually factor the alpha out. Okay, so you can basically just take this alpha out front and then just do the M transpose. So you don't have to do the multiplication first and then transposing. You can do the transposing and then multiply the alpha in. So you can do it in two different orders, right? And then the last big property is, imagine you have two matrices being multiplied together and you transpose them. Well, actually something interesting happens. It doesn't just distribute like it did up here, right? Up here you just distributed and you just had, transpose of each added together. Here you distribute, but you also have to switch the order around. So it becomes N transpose times M transpose. So we had to switch the order of M and N. So that's interesting, right? And this can be extended, right? Say we had like three matrices. What we would do is we would swap the order around and look at the transpose of each one individually. And it goes on and on. You can have however many matrices you want. You just have to switch the order around. Okay, so these are our three properties. And we're going to be thinking about these as we go through these problems, okay? Cool. So, problem A. We're trying to calculate A plus B transpose. Now, what have we been given? We've been given A transpose, B transpose, and C transpose. We've been given the transposes of the matrices, but not the original matrices. Now, we could find what the original matrices are, right? If we just take the transposes of these, we'd get back our original matrices. But we actually don't have to. We can just use the properties of matrices to figure out what this answer is. So remember the properties, if we're adding matrices together and transposing that, that's the same thing, we can distribute it in. So instead of having to find A and B and add them together and then transpose, instead we can just use the transposes and add those together. So what is A transpose? Well, that was given to us right here, right? It's -1, 4, 2, -2. And what is B transpose? That was given to us right here. And we're adding them together. Okay. And then remember how matrix addition works. We do it component-wise. So top left would be -1 plus 3. Top right would be 4 plus 0. Bottom left would be 2 plus 0. And bottom right would be -2 plus 7. So this is our answer to part A. Okay, now we go on to part B. Part B. So we're looking at A, C, B transposed. So again, just like with the first one, we could find out what A, B, and C are if we wanted to, right? We could calculate them from these guys and then multiply those together and then transpose it. Or we can just use the properties of the transposition. So what happens when you're multiplying? You flip them all around and you transpose each of them. So instead of ACB, it's now B transpose C transpose A transpose. So we're multiplying these three matrices together. So what is B transpose? It's 3, 0, 0, 7. What is C transpose? -3, 2, 6, 3. And what is A transpose? -1, 4, 2, -2. Now, how we do this multiplication, it's entirely up to you. You can choose to do these two multiplied together first, and then take that answer and multiply here. Or you could choose to multiply these two together first, the back half, and then multiply that answer by this. So the order you do it in is up to you. You have two options. I'll do this multiplication first, because I already have that bracketed in. So we remember how matrix multiplication works. You take rows times columns. And if you don't remember how matrix multiplication works, we have a video for that. So go ahead and check that out. I'm not going to spend too much time on the multiplication in this video, because that's not the focus. So we'd have -3 times -1, which is 3. 2 times 2, which is 4. 3 plus 4 is 7. Then we would move on to this next column. -3 times 4 is -12. -4 becomes -16. Then we move down here and we repeat the process. So 6 times -1 is -6. 3 times 2 is 6. -6 plus 6 is 0. And 6 times 4 is 24. 3 times -2 is -6. 24 minus 6 is 18. And then we have to do one more multiplication. I'm going to do this up here. So similar process, we do the multiplication. We're going to get 21, -48, 0, and then 126. So again, not focusing on the multiplication, just more the concept of the transpose in this video. Cool. So that's what part B ends up becoming. I'm going to go ahead and clear this out, and then we'll do part C, our last one. So our last one, we're taking alpha C transpose, where alpha is 1/3. So remember, again, properties. You can take the alpha out front, and you're just going to be multiplying that by C transpose. So we have 1/3 times C transpose, which was this guy. And remember how scalar multiplication works, you can just distribute it inside. So we have -1, 2/3, 2, and 1. That's what part C becomes. Cool. So those are all those are your major properties of the transpose. All right. Well, thank you for joining me. As I mentioned at the beginning, I work for the ASU tutoring centers. If you want more information about the free services that we offer on all 4 major campuses and online, please go ahead and check out tutoring.asu.edu. If you want more videos like this that go over specific concepts from your course, or maybe you want to see what upcoming review sessions we have for the exams in your course, go ahead and check out that link down there. Thank you all again, and have a wonderful day.